Hey everyone, today I'll be talking about one of the worst possible malignant neoplasms that you can get in the brain. This is the neoplasm, and unfortunately, it is the most common neoplasm or most common malignant neoplasm that arise in the brain and is usually seen in the elderly population. It is the glioblastoma. Previously, it was known as glioblastoma multiforme, but now the term is just glioblastoma, and it corresponds to histological grade of grade 4. That is the highest histological grade possible. And how the grading is, we'll just see. The grading of Cns tumors is basically if you have an aplasia, that is the difference in cell size and morphology, that is what you call as grade 2. And if there is mitosis, here you can see one mitotic figure. So if there is an aplasia plus mitosis, that becomes grade 3. So in this field you can see both an aplasia as well as mitosis, and I already told I'm talking about glioblastoma, and it is a grade 4 neoplasm. So there are more to see in this slide. Anyway, first is an aplasia. In case of grading, you will call it grade 2. If there is an aplasia plus mitosis or increased mitosis, atypical mitosis, you call it grade 3. And if there is microvascular proliferation or necrosis of any type, that will become grade 4. In glioblastoma, there will be microvascular proliferation or necrosis, and we will see that in this slide. So just talking about the grading system, we can remember it from grade 2 to grade 4 by code AMEN, that is AMEN, AMEN, that I got from Dr. Ari Perry, a talk of his that I saw in YouTube. Like anaplasia A for AMEN, A, MS mitosis, and A there's endocapillary proliferation that you can just extrapolate to microvascular proliferation in your mind, and N is necrosis. So that is how you grade CNS tumors. So let's go to this case. In this case, or in this view, you can see this field. You can see an aplastic. There's increased cellularity. First thing is the cellularity of this area is completely increased, and it is not composed of a uniform population of cells. You can see that the cells have a completely different morphology when you compare each cell to the other. It is not a monomorphic population. The cells have different varying shapes and sizes, and there is also nuclear. The chromatin has a variation in their appearances from cell to cell or nucleus to nucleus. So there is anaplasia. Then you can see mitosis, as I already pointed out. And so in this field you can see anaplasia and mitosis. The next things that we expect to see in this case is necrosis and microvascular proliferation. So let's go on to that in other areas. So going in this field, if you look, there is microvascular proliferation, and a definition of microvascular proliferation is if you can have what is a normal layer of endothelium? Endothelium normally has only one layer. A blood vessel usually has only a single layer of endothelium. But in case of microvascular proliferation, you'll see that there will be multi-layering of endothelium. You can see this number of vessels are increased in this field. A lot of action, or a lot of capillaries can be seen, newly formed vessels. And let's focus on one of them. Let me see a good one. Yes, let's see here, this place. Okay, if you look into this, you can see that there is multi-layering of the endothelium. That is, it is not a single layer of endothelium that you see. Microvascular proliferation by definition can either be multi-layering of the endothelium, or you can see glomerulus like structures, glomeruloid vasculature. So if you see either glomeruloid vessels or you see multi-layering of endothelium, either of that, so you can see multi-layering very nicely, either of that will qualify as microvascular proliferation. So you can see anaplastic cells, there was mitosis, increased mitosis, some of which were atypical, and then there is multi-layering. In this slide I did not see glomeruloid capillary proliferation, but multi-layering and increased vasculature is seen quite evidently. The next thing that we expect to see is necrosis. And necrosis, sometimes it is characteristically called palisading necrosis, in the sense necrotic area will be surrounded by tumor cells, or in a palisading manner. It will be bordered by the tumor cells in a beautiful manner. Let's see how, if we can see a good area somewhere. Yeah, here. If you see here, you can see this is a necrotic area. That is a eosinophilic area that is necrotic, because it is necrosed off. It is completely eosinophilic with no viable cells, and surrounding you can see tumor cells that are linearly or bordering the necrotic area. The tumor cells arrange itself around the necrotic area or border the necrotic area. That is what you call a palisading necrosis. When you go to higher power, you can see that much better. See, this is the necrotic area, and this is the tumor cells that are surrounding the necrotic area or palisading it. So in this slide you can also see other kinds of necrosis. Large areas of necrosis was also otherwise seen. I mean, not just the palisading necrosis. See, the whole area is necrosed off. This is not palisading here, but it is just necrosed off. So in this slide you can see this is other necrotic area. So in this slide what we saw is anaplasia, increased mitosis, many of which were atypical, then microvascular proliferation, and necrosis, many of which was palisaded by tumor cells. So this is the histology that we expect to see in glioblastoma. That is a grade 4 CNS tumor or astrocytoma, or so that is the worst form of astrocytoma that you can get. It's a grade 4 tumor. Thank you.